Look up tonight and you will see about 4,000 stars. Each one is a sun. Most have planets. Our galaxy holds at least 100 billion more. And there are about 2 trillion galaxies beyond it, each one a Milky Way of its own. By every honest estimate, the universe should be full of life, and yet the sky is completely silent. No signals, no probes, no visitors. Just us, on a small, wet rock. Alone. Surrounded by an entire universe that does not answer back. And the most unsettling answer is also the simplest one. We really might be the only ones. And the math says that should be impossible. The first person to point at this problem was eating lunch. In the summer of 1950, 4 physicists walked into Fuller Lodge in New Mexico. Enrico Fermi, Edward Teller, Herbert York, Emil Konopinski. They had been joking about UFO sightings in the newspaper. A New Yorker cartoon had blamed aliens for missing trash cans. They sat down. Fermi went quiet for a moment. Then he said, "Where is everybody?" Everyone at the table laughed and understood instantly. He was right. The math made no sense. Stars older than our sun should have grown civilizations a billion years ago. Even at slow speeds, those civilizations could have colonized the entire galaxy. It would take a few million years, a blink in cosmic time. So the galaxy should be crawling with traces of them, but every direction we look, the sky is empty. That gap between expectation and silence is the Fermi paradox. In 1961, an astronomer named Frank Drake tried to put numbers on it. He scribbled an equation on the board at Green Bank Observatory, a radio telescope facility tucked in the West Virginia hills. Multiply 7 numbers, and you get how many civilizations could be talking to us right now. Plug in optimistic values, and you get thousands. Plug in pessimistic values, and you get less than 1. Nobody knows which numbers are right. Each variable has hundreds of competing estimates, and that is the problem. We are guessing in the dark. In 1996, an economist at George Mason University proposed the darkest version of the idea. Robin Hanson called it the Great Filter. Imagine every step from dead matter to a galactic civilization. Hanson listed 9 of them. Right star, right planet, self-replicating molecules, single cells, complex cells, sexual reproduction, brains, tools, and then the leap into the stars. Somewhere along that ladder, something stops almost everyone. And that is where it gets terrifying. If the filter is behind us, we are unbelievably lucky. Some step we already passed was a near impossible coin flip. Maybe the jump from dead chemicals to the first cell. Maybe the jump from single cells to complex ones. That took our planet about 2 billion years. Bacteria sat alone on Earth for almost half its history. If those steps are that rare, we might be the first in our part of the galaxy. But if the filter is ahead of us, the answer is much worse. It means almost every civilization that reaches our level destroys itself. Nuclear war, engineered pandemics, runaway technology, climate breakdown, asteroid strikes, filters we have not even named. Hanson's logic was simple. Every civilization that crosses the filter spreads. If even one had crossed before us, we would already see it. We do not. So almost nobody crosses. The question is why, and which side of the filter we are standing on. There is another camp that thinks the answer is older than civilization. In 2000, geologists Peter Ward and Donald Brownlee published Rare Earth. Their argument was that complex life needs a long list of coincidences, hundreds of them, all stacked in one planet's favor. The right kind of star, a stable orbit, a large moon, a magnetic field strong enough to deflect radiation, plate tectonics that recycle carbon for billions of years. Without it, the air freezes or boils. A planet like Jupiter nearby to soak up asteroids. Miss any of them, and the planet stays a bacterial soup forever. Bacteria are common, cities are not. In that view, the galaxy is not empty. It is full of microbes. Just no one to talk to. Then there is the strangest answer of all. They are out there. They are hiding from us. The Chinese novelist Liu Cixin called this the dark forest. Every civilization is a hunter in the woods at night. You cannot tell who is a friend. You cannot tell who is a threat. Anyone who reveals their position can be destroyed by anyone better armed. From across the galaxy, with no warning. So the only safe move is to stay completely silent. Listen, never broadcast. Whisper to your own walls, and never the wider sky. In the dark forest theory, the sky is silent on purpose. Every civilization that ever broadcast loudly was already wiped out. We have been screaming into space since the 1930s. Our television signals are out about 90 light years by now. Thousands of star systems could already have heard us. And nobody has answered. Not one reply, not one signal, not one ping. There is a softer version of this, too. In 1973, an astronomer named John Ball proposed the zoo hypothesis. They know we are here. They are watching. They are leaving us alone the way we leave animals in a wildlife reserve alone. Quiet, observed, not interfered with, like a child in a glass tank. Maybe to see if we figure it out. Maybe to see how long we last. We pass the test, or we are quietly removed. Each of these answers feels uncomfortable, because all of them, including the silence, point at the same thing. Something is keeping the sky empty. And the empty sky has a meaning either way. If we are alone because life is rare, then every species that exists is a miracle. If we are alone because the filter kills civilizations, then we are next in line. If they are hiding, we have been waving a flag at the wrong forest. All three answers end with us responsible for what happens next. And here is the part most people miss. It changes the meaning of everything. If we are the first to make it, the silence is not a warning. It is a job. Every civilization has to start somewhere. If life is this rare, the universe needs witnesses. It needs someone to look back at itself. Atoms arranged in a way that can ask questions. That might be the only role we get. And no one else will ever show up to share it. And it might be enough. One single witness can justify an entire universe. Carl Sagan put it in one line. He wrote it in his book Cosmos in 1980. We are a way for the cosmos to know itself. If that is true, every silent star above your roof tonight has a meaning. Each one is a planet that never spoke, or a planet that died before it could, or a planet still waiting for us to grow up enough to find it, hidden behind a star we have not pointed a telescope at yet. The scariest answer to the Fermi paradox is not that they are gone. It is that we might be the only chance the universe gets, and what we do with that fact is the only signal we will ever send.